All right, welcome back, students of marine science. Happy to have you here for lesson 2.1, Earth structure and ocean formations. Starting our second unit, there's going to be 4 lessons total throughout this unit. One of them is going to be mostly independent, but I'll walk you through that one as well and make sure that we're all on the same page. For this lesson, just keep in mind, since you're watching it via video, that you have the ability to pause and hit play as many times as you need to keep up. And don't forget, if you are in one of the standard sections of this class, of this study guide, does earn you that extra 5% bump to your test. So make sure that you're doing a good job keeping up with these notes. Also, I'll mention this is being recorded on a Wednesday, so forgive the casual attire, but on Wednesdays teachers are encouraged to wear their college gear. So I've got the Flagler shirt going today. Go Saints. All right, let's go ahead and start walking through our lesson here. Nothing that you need to write off of this screen, just a little introduction here. The world ocean is the dominant feature on Earth in terms of total area as far as the surface of the Earth goes. We already knew this from Unit 1, that 71% of the Earth's surface is water, and most of that is ocean. In total area, the northern hemisphere is about 61% water, and the southern hemisphere is about 80% water. Pretty incredible. The world ocean is divided into 5 large basins. The word basin basically means bowl. The bowls that are formed on the Earth's crust that collect the water. They're large enough bowls that this water collects and creates our oceans. So the 5, this is where you're writing now for number 1. It says describe the 5 ocean basins that are found on Earth. We'll walk you through each one. The Pacific is the largest and the deepest. The Atlantic is the second largest, and it is home to the largest ridge. If you don't know what ridge I'm talking about or what I mean by that, I'm going to let you just hold on to that until lesson 2.3. We'll come back to that and answer that question thoroughly. The next one is the Indian Ocean Basin. This is the 3rd largest, and even so, as the 3rd largest, it's still about the size of 5 United States of America, so still very, very large. And then from there we have the Southern Ocean. This is the most recent to be named. Used to be considered 4 basins, and now we consider 5. This one being kind of under the southern tip of Africa. And then we go north now for the Arctic Ocean Basin. This is the smallest and shallowest of our ocean basins. Going on to question number 2 here. How is Earth thought to have originated? The Earth is thought to have originated about 4.5 billion years ago from dust that accumulated from the Big Bang. There are, of course, other ideas out there as well, but among scientists, this number and this theory are the most prominent. Due to the heat associated with the events around the Big Bang, the early Earth was likely very molten, and this allowed the materials to settle based on density. You'll hear that word density coming up over and over again throughout this lesson. The Big Bang itself, we're moving on to number 3 here. What is the Big Bang, and is the universe still expanding? The Big Bang is a theory that states that the universe expanded from a very high temperature and high density state approximately 14 billion years ago. If you need help remembering that, if you're a fan of the show The Big Bang, the theme song and that tells us that the whole universe was in a hot, dense state. That might be able to help you remember. The other thing that we want you to know in terms of Big Bang is that we are able to measure the fact that the universe is still expanding and in fact accelerating. We can kind of figure out a point of origin, and from there we can see that things throughout the universe are moving farther and farther apart from each other and at a faster and faster rate. Nothing to write here. We just want to point out real quick, contrasting the inner 4 planets and the outer 4 within our solar system. Still hurts me a little bit as a child of the 80s to say there are only 8 planets. We miss you, Pluto, but it is what it is. So the inner four, as you can see, are very small compared to the outer four. These inner four have very, very large cores, as the outer four are mostly gaseous with very, very small cores at the center of them. So here we come back to our term density. This is answering number 4. What is density stratification? Describe the density stratification of Earth. So density is measured in mass per unit volume of a substance. And the density stratification of Earth is based on layers. Density stratification is the idea of there being layers. And Earth is most dense at the center, and then the layers get less and less dense as you come out from the center of Earth. Here's a little experiment that you can try at home with permission from your parent or guardian, of course. You take a cup and get these 5 different substances. We've got vegetable oil, water, dish soap, corn syrup, and honey. And it does not matter what order you pour them into the cup in, they will eventually settle in this order. The honey is the most dense, and so it will settle at the bottom, and then the corn syrup and the dish soap, etc., they settle based on density. And that's exactly what happened when the early Earth was in a pretty molten, liquidy sort of state. The more dense items went to the center and pushed out the less dense items, and gave the properties of a density stratified Earth. The structure of Earth, kind of like I just said, the heavier materials settled deep in the Earth. The lighter components were then pushed out, and they formed a thin crust. Eventually, the Earth's oceans and atmosphere began to form, and the location of the Earth relative to the sun allows for us to have water that stays in its liquid form. This is incredibly important for the idea of there being life on Earth. If it were not for that perfect distance from the sun that allows water to stay in its liquid form, if it were not for that, there would not be life on Earth. Excuse me. The internal structure of Earth, we've got the core, the mantle, and the crust, and each of these can kind of be broken into an inner and outer layer as well. So the core is the innermost layer of Earth. It is the most dense, the most solid. It is very rich in iron. The mantle, the middle layer, is semi-plastic, which kind of means it's almost kind of stuck in a weird state of being half liquid, half solid, kind of in that in-between phase. Kind of like, if you've got some queso, and that top layer eventually, after it sits there for a while and cools off, it kind of starts to get hard a little bit. That's kind of the mantle, that plasticky state in between a solid and a liquid. And then we've got the crust. It's our outermost layer. It is the thinnest portion of Earth. And really what I want to show you here, you can just kind of see based on the numbers what we've been saying. This is the highest of the numbers, and they get smaller as we go up. So this high number means that this is the most dense layer, and then we see the density getting less and less as we work our way out toward the crust. And then here's what we're writing for number 5. The last thing that we're going to fill in our sheet. We do have a couple more slides after this one, so stay with me. But the last thing that we're going to officially write on the sheet is going to break down the components of some of our layers. As I said, the mantle and core can both be broken up into an inner and outer layer as well. We're not going to do that for the sake of our graph here, but we are going to break up the crust into continental crust and oceanic crust. So for continental crust, remember, if I go too fast, hit pause. But continental crust is going to be composed primarily of granite. It is the least dense of all the layers. And then below that, you've got your oceanic crust, which is composed primarily of basalt, and it is a little more dense than the oceanic crust. Not much, but a little more dense. It's still a part of our crust. And then we get to our mantle. Our mantle is composed of a number of different things, including mostly silicon, oxygen, iron, and magnesium. It is very, very dense. However, it is not the most dense. We've still got our core. Our core is mostly of iron, and it is by far the most dense out of all of them. Just to give you a little picture here, I mostly show you this just to demonstrate how thin the Earth's crust is compared to our other layers. You can see that the other layers are much thicker. As deep as some of our oceans go, as incredibly deep as they are, it's hard for our brains to kind of wrap around this. As deep as our oceans are, they are still incredibly shallow compared to how thick these other layers are. It's an interesting thing to think about. And then I do want to mention this. We're going to come across this again in lesson 2.3, but really I would love for you to go ahead and write it at the bottom of your sheet here. You've got some room to include this at the bottom. This is a really important fact that we want to make sure that you understand. Oceanic crust is made up of dark colored mineral basalt, denser than continental crust. It is younger than continental crust. So we go ahead and jot that down now at the bottom, and then we'll probably get again on 2.3 as well. But we want to make sure that you've got that oceanic crust is going to be younger, and explaining why is going to be an important part of what comes into plate tectonics. Then we got our continental crust, light colored, mostly granite, less dense. All stuff that we've covered before. And our last slide here, we've got a chart. You can pause this and take a look at it if you want, but really we've already kind of summarized all this information. This just gives you another way to take a look at it. If you prefer this kind of graphic form of the information, then you can take a look at it there. Otherwise, that is the conclusion for lesson 2.1. I'll see you later.